Hi, this Booster BIM video is about wondering why Revit doesn't implement spell checking for schedules. We can see here I have a schedule on a sheet, and when I run check spelling, as you may know, spell check is completed even though there's a bunch of misspelled words here in my schedule. So what we're going to do is take a look at how we can use Revit's API, put that together with this Microsoft Bing spell check web API to do some spell checking in our schedules. So first we'll run the macro I've written. You can see here what it's done is it's showing us the raw JSON data that's come back from the Bing API. And here I've formatted that to a bit nicer appearance, and you can see here are some words that are misspelled: family, hello, comments, misspelled two different ways. We have the misspelled word on the left, and then suggestions that are returned from the Microsoft API shown on the right. This implementation does not actually correct the spelling, which we'll talk about in a bit, but certainly could be enhanced to do that. So if we come and look at our code, well, I guess we can first take a look at that Bing API code and see that they've given us some pretty good C# code here that I've basically cut and pasted into my routine. We'll start off by checking that either a schedule or sheet is the active view. Then I'm going to build a list of schedules. If the active view is a sheet, that list of schedules will be those schedules that are on the sheet. We look for schedule sheet instances that are owned by this sheet view. And then we're going to get the schedules from their sheet instance using the sheet instance's schedule ID property. And then we also want to make sure that we're not getting any title block revision schedules for the purpose of this demo. If the active view is a schedule, we just use that schedule. In this routine, we're going to go through each schedule. We're going to get all of its cell text and then pass that cell text to the spell check routine that, again, came the basis of which came from Microsoft. So here's their spell check routine. You can look at it on their website if you'd like for more detail. Basically what we're doing is we're going to send a web message. The results come back here. This task is the task dialog that showed sort of the raw JSON with some formatting from this Microsoft provided function. What I'm going to then do with that JSON data is deserialize it. So we want to go from, and if we run this, right, we can start off with something like this. Here's the JSON. We can see that it's built of, you have a list of suggestions. Each suggestion has a suggestion, which is the string of the suggested word, and it has a score showing how good of a suggestion Microsoft thinks that is. Then we have some other data, offset, which is telling us where in the string that misspelled word is. The token is actually the misspelled word, and the type is telling us that that is an unknown word. So it's using the word token instead of the word word, but that's their API. So what we're going to do here is we're going to serialize that. So what I've done, if we take a look at this code, is we've created some classes. I have a suggestion class, and that has a suggestion, which is the string, and a double, which is a score, which we can see sort of corresponds to the data inside each one of these suggestions. Then we have what, again, they call here in their API a flagged token. So the flagged token has the token, which is the string, which is that word, and it also has a list of those suggestions, right? A list of this instances of this class. It has a few other things, as we said, that has an offset and a type. I don't really care about those for this implementation, so it didn't bother to implement those. And then the whole thing is going to be a list of these flagged tokens, right? So we can see that we have a set here, right? This first one for family, the second one for hello, the third one for comments, and so forth. So by using this JavaScript serializer and its deserialized method, we were able to convert that JSON data here into a flagged token list of elements. We then go through that list and get each one of these flagged tokens, and then from that flagged token, which again would be one of these specific tokens where we have the misspelled word and then the list of suggestions, I'm going to get that list of suggestions using this link query. If there are no suggestions, I'm just going to skip it. Then I'm going to add to my list of output strings the name of the flagged token or that incorrect spelled word, and then join together a list of all those different possible suggestions. And then we create the task dialog to show the whole thing. So again, that gets us, we go from here by deserializing and then sort of reformatting that, we get this much more palatable list of misspelled words and their suggestions. So to answer the question of, well, why don't we then go ahead and start a transaction to let the user pick a new spelling and actually change the word? Well, the issue there is that this spell checking is done in an asynchronous method. Right? This is to let you go off to the web and wait for the response to come back. And as you may know, Revit does not let you sort of do work from sort of the non-primary thread. So if we tried to create a transaction here inside this asynchronous spell check method, so you could say down here, well, we have the token, we have the suggestions. Let's let the user pick a suggestion now and actually use, instead of get cell text that we used up here, we could then start using set cell text to set it to one of the suggested spellings. Well, that's not going to work, again, because we would be doing that in this asynchronous situation. We could do this by using Revit's external events framework, and that's well documented both in the Revit documentation and elsewhere, in case you're interested in taking this to the next level.